And next is we're going to find the derivative of the curvature of the function y is equals to sine x at x is equals to 0 and x at 1/2 pi or 90 degrees. So first is we're going to find the first and derivative of this function. The derivative of this function is cos x, and the second derivative is negative sine x. So using again the formula, which is the curvature is equals to the second derivative over to the quantity 1 plus dy dx squared raised to the power of 3 halves. So again, substitute our first and second derivative. So we get our second derivative is negative sine. So this is our numerator, negative sine x over quantity of 1 plus the quantity of cos sine x squared raised to the power of 3 over 2. Since we are given the value of at x is equals to 0, so substitute the value at negative sine 0 over 1 plus cosine 0 squared to the quantity of 3 halves. Since sine 0 is 0 over 1 plus 1 or 2 raised to the power of 3 halves, and 0 over any number is 0. So meaning to say that there is no bending happens at point x at x is equals to 0. And next is we're going to find the curvature at x is equals to 90 degrees or 1/2 pi. Again, using again the formula, the second derivative over the quantity of 1 plus dy dx squared to the power of 3 halves. Substitute the first and second derivative value, and the second derivative is negative sine x over 1 plus cosine x squared raised to the power of 3 halves. So that's negative sine 90 degrees over 1 plus cosine 90 degrees raised to the power of 2 over to the quantity of 3 halves. So we get sine negative 90 is negative 1, and 1 cosine 90 is 0. So 0 squared is 0. 1 raised to the power of 3 halves is 1. So our answer is negative 1. So the curvature is negative 1. This is the answer of this given.